Okay, so this is page number 5. Fine tuning agility. Parameter efficient, for example, LoRa, LORA, and DORA, DORA, low resource and full parameter fine tuning for SLMs require only a few GPU hours, allowing behaviors to be added, fixed, or specialized overnight rather than over weeks. In this, LORA stands for LORA. This is low rank adaptation of LLMs, and DORA stands for weighted decomposed low rank adaptation. Edge deployment. Advances in on-device inference systems such as chat RTX demonstrate local execution of SLMs on a consumer-grade GPUs, showcasing real-time offline agentic inference with lower latency and stronger data control. Parameter and embedding space utilization. At the outset, LLMs appear to operate as monoliths involving a large amount of parameters representing swaths of compressed information in the production of their outputs. On a closer look, however, many of the embeddings passing through these systems are very sparse, engaging only a fraction of their parameters for any single input, and being effectively compressible. That this behavior appear to be more subdued in SLMs, suggests that SLMs may be fundamentally more efficient by the virtue of having a smaller portion of their parameters contribute to the inference cost without a tangible effect on the output. Modular system design. The position outlined in reference 56 represents a thorough argument in favor of composite agentic systems. Here we note that the approach of leveraging several models of varying sizes align well with the real-world heterogeneity of agentic tasks and is already slowly becoming incorporated into major software development frameworks. Furthermore, this newly discovered sense of modularity in the context of agents allow for the easy addition of new skills and the ability to adapt to changing requirements, and is consistent with the push for modularity in language models design. The above mentioned Lego-like composition of agentic intelligence, scaling out by adding small specialized experts instead of scaling up monolith models, yields systems that are cheaper, faster to debug, easier to deploy, and better aligned with the operational diversity of real-world agents. When combined with tool calling, caching, and fine-grained routing, SLM-first architectures appear to offer the best path forward for cost-effective, modular, and sustainable agentic AI. Coming on to section 3.3, SLMs are more flexible. A3, that is argument 3, SLMs possess greater operational flexibility in comparison to LLMs. This argument stands in support of view V2, and V3. Due to their small size and the associated reduction in pre-training and fine-tuning costs, SLMs are inherently more flexible than their large counterparts when appearing in agentic systems. As such, it becomes much more affordable and practical to train, adapt, and deploy multiple specialized expert models for different agentic routines. This efficiency enables rapid iteration and adaptation, making it feasible to address evolving user needs, including supporting new behaviors, meeting new output formatting requirements, and complying with changing local regulations in selected markets. Democratization. One particularly notable and desirable consequence of SLM's flexibility when put in place of the LLMs is the ensuing democratization of the agents. When more individuals and organizations can participate in developing language models with the aim of development in agentic systems, the aggregate population of agents is more likely to represent a more diverse range of perspectives and societal needs. This diversity can then help with reducing the risk of systemic biases and encourage competition and innovation. With more actors entering the field to create and refine models, the field will advance more rapidly. Coming on to section 3.4, agents expose only very narrow LM functionality. A4 argument 4, agentic applications are interfaces to a limited subset of LM capabilities. This supports views V1 and V2. An AI agent is essentially a heavily instructed and externally choreographed gateway to a language model featuring a human computer interface and a selection of tools that, when engaged correctly, do something of utility. From this perspective, the underlying language models that was engineered to be a powerful generalist is through a set of tediously written prompts and meticulously orchestrated context management restricted to operate within a small section of its otherwise large palette of skills.